All right, the next property has to do with angle subtended by the same arc or chord, okay, anywhere in the same segment are equal. So if there is a chord, okay, so we have an angle forming here, okay, we have another one here, the same chord, we have another one here, okay, same chord. Okay, so let's call this one chord XY. All right, so once it happens this way, the angle here, this side is X and this side is Y, this side is Z. Okay, let's call this side X, M, and P. So we have angle XMY, that is X. Okay, so X is the same as Y. Okay, X is the same as Y, the same as Z. So angle XMY, this one, the same as this and the same as that. Okay, because of this, let me call this one TK. Okay, TKM. So angle X is the same as angle, so the middle one TMK. TMK. And the same as Y. Y is TNK. TNK. And the same as P. TPK. Angle TPK. Okay, which is the same as X, Y, and then Z. All right, so if this side is 30, this side will be 30, and this side will also be 30. All right. Okay. Now, we also have equal cos, okay? Equal cos or arc, subtended equal angles at the center and the circumference of a circle. So we can have equal cos at the center here. So let me get a chord here. Let me do it well. So, okay, and we have another one here. So we have a chord, we have a chord. It means the angle here is the same as the angle here, okay? So if this side is 40, this side is also 40. All right. So we have a chord here. So, and we have the one here. So another chord, okay? So the angle here, this side is X, this side is equal to Y. So angle X is the same as Y, okay? That's that, okay? So if this side is 40, this side is 40. Okay. All right. Now we want to talk about a diameter, okay? We know what is meant by diameter. So any angle subtended at the circumference of a circle by its diameter, okay, is a right angle or it's 90 degrees here. So in case in the question it says if XY is a diameter, it means the angle that subtends here is 90 degrees, okay? It's 90. So let's look at another scenario here. So in case you have, let's say, a diameter, okay, say AB is a diameter, okay, it means the angle that subtends the circumference here is 90. But if this side is, let's say, 20, and you're asked to find angle angle ABC. If AB is a diameter, okay. Now, once AB is a diameter, the angle that forms the circumference here is 90. So this one will be angle BAC plus angle ACB plus angle ABC equals to 180 degrees. So the sum of angles in a triangle add up to 180. So we have BAC as 20 plus ACB as 90 plus ABC. So let's call the side X. ABC X equals to 180. So we have 110 plus X equals 180. So X is 180 minus 110. So X is straight away 70. So this side is 70. Okay. That's the diameter of a circle. Okay. How powerful it is. All right. Okay. Now the next property has to do with angle between the chord and tangent. All right. Now the angle between the chord and tangent is equal to the angle in the alternate segment. So if this side is theta 1, so in alternate segment this side will be theta 1. Okay. If this side is theta 2, let me use different color. So if this side is theta 2, this side is the opposite or alternate. This side is the alternate segment, that will be theta 2. Okay, so that's that. So if this side is 30, this side will be 30. And if this side is 20, this side will be 20. So that is the angle between the chord and the tangent. Okay. All right. Now let's talk about this. Okay. So we have 50 here. We have X here. We have 25 here. We have Y here. Then we have M here. Okay. So if you have to solve for M, X, Y. Okay. So from here, Y is 50. Then X is 25. And this one is angle in a straight line, which add up to 180. That will make this side go to 180. All right. So after this, we are going to solve so many examples. So don't worry about the examples. Okay. All right. Now let's talk about the cyclic quadrilateral. If this one, okay, we have 4 points quad touching the circumference. Okay. We call it a cyclic quadrilateral. So once it happens, the sum of the opposite angles add up to 180 degrees. So A plus D is straight away 180 degrees. Then B plus C is also 180 degrees. All right, so this one is called a cyclic quadrilateral. All right. Okay, so if this side is 70 and this side is Y, so what is X? So it's straight away adding the two and equating them to 180. So 70 plus X is 180. Therefore, X is the same as 180 minus 70. So X is straight away 110. Remember, when we sum the two, you get 180. And if this side is 60, you should know this side as 120. All right, so that's that. Okay, so I will talk about the tangent to a circle. Okay, remember, if a line touches a circle at only one point, it's called a tangent. Now, we have a tangent here. So once this side is a tangent, this side is 90 degrees, okay? And we have another one here, 90, okay? Now, if this side is M, this side is M. Remember, we have radius from here to here is radius, so they are equal, and therefore this side is equal to that, okay? And once this side is equal to that, it implies that this side is also equal to this side. So if this side is 20, this side will be 20. And this side is 40, this side will be 40. And don't forget that this side plus this side plus this side will give us 180 degrees. Likewise here, plus there, plus over there will also give us 180 degrees. As simple as that. Now, let's talk about the first example. Now, before we talk about the first example, the sum of angles in a triangle, okay? If this side is alpha, theta, and this side is beta, alpha plus theta plus beta will give us 180 degrees, okay? Now, when we have two parallel lines like this, okay, and this one is a transversal, we have so many properties. So if this side is x, okay, so this one corresponds to that, so this side too is x, and this, if this side is t, we have vertical opposite angles, x equals to t, and remember x alternate to t, so we have an alternating angle here, tx. If this side is m, this side is opposite. If this side is u, okay, once we sum this one, we get 180. So the angle here is the same as the angle here. All right, so that's that. Now, knowing these things will help us, solve a lot of examples, okay? All right, so let's start with our first example here. So now that we know the properties, we can solve this example. So let's call this side A, B, C, okay? And we have O. All right, now we had solved for x. So our x will be angle AOB. Now remember the first property, okay? The angle at the center is twice that of circumference. So when we have this, not drawn to scale, now if you have something like this, okay, an angle at the center and that of circumference. So if this side is k, this side is 2k. Now we have 70 here, so this side will be double, okay? All right, so that's the first property. So angle AOB, okay, the same as twice of ACB. Now the middle one is our target, so ACB means that this side 70. So 2 times angle ACB. So angle AOB is twice of that. So this side will make it 2 times 70, which is 140 degrees. So this side is 140. Okay, so that's our first example. All right. Now let's talk about our second example. Remember the angle at the center, okay? That is twice that of circumference. Now, the angle forming at the circumference can be formed at any point on the remaining part of the circumference. So, remember the first one we solved, we found our angle here, but this time it has been pushed down here. Okay, so the value is the same, the theorem still remains the same. So what we have here, okay, is twice of that. So same thing, angle B is 2 times angle ACB. So this is ACB. And what is ACB? ACB is 120, so 2 times 120, that will be 240 degrees. So AOB is now 240. Remember, when this side is given, we should be able to solve this by dividing this side by 2. Okay, now let's talk about the next example. Yes, so this time we have the angle at the center. So let's see how the angle at the circumference will be. All right, so remember the theorem which says the angle at the center is twice that of circumference. So angle AOB is 2 times angle ACB. That is what we know, but we know AOB as 100. So I'll put 100 here. 100 is the same as we after this side. So AC is what we are after, okay? So ACB, this side be 2 times angle ACB. Now many students find it difficult to write this thing, so they normally represent this side by variables unknown, like saying ACB is P, then they put P here. Okay, so you can go ahead with that. So let's divide this side by 2. So this side will cancel. So we have 50 equals angle ACB. So once we double this, you get this. All right. Okay, now we have to solve for angle AOC and X. Now remember that we have 2 segments here. Now let's put A. Okay, this is the first segment. Okay, now a segment. Now look, angle in opposite segment. So this is the first segment, and we have another one here. Okay, now forget about the angle at the center here. Okay, now the first segment and the second segment, once you put them together, you get 180. So if this side is X and this side is Y, the sum of angle in opposite segment give 180 degrees. So that will help us solve for X. After that, we'll come back to O. Now don't forget that we just saw an example of this nature. So the angle at the center, this is a chord, AC is a chord. The angle at the center here is twice that of circumference. So AOC is simply twice of 80. Okay, that will be 160. So this side is 160. We just solved 2 examples here. Now to find X is simply angle ABC, that is X, plus angle ADC, that is 80, equals 180. So angle ABC plus 80, ADC, this is ADC, ADC equals 180. So angle ABC equals 180 minus 80. So angle ABC is straight away 100 degrees. So this side is 100. So the sum of these angles gives us 180 degrees. Okay, that's that. All right, now let's solve this question with ease. So this one is not all that difficult, okay? So let's understand this one again. So there's angle at the center, okay? Then angle at the circumference. So I can choose, let me call this X, and I can choose to push X to this place, okay? That is here. And I can also push this one to this side. So that is R. Good. But remember, we were not given this side, we were given this side. And remember, this angle at a point. So we have it here, angle at a point. So it add up to 360 degrees. Okay, so we are going to find POR reflex. Now let me explain this one here. Now we have POR. So we have at the back here and we have in front here. So one is reflex and one is obtuse. Okay. Now obtuse is less than 180. Okay, but more than 90. Reflex is also less than 360 but more than 180. So guess which side will be the reflex and which side will be the obtuse. So the 100 will be the obtuse part. So angle POR obtuse plus angle POR reflex will give me 360 degrees because there's angle at a point. So everything here will be 360. So with this 100, okay, 100 plus angle POR reflex will give me 360. So angle POR, that's the reflex, okay, will be 360 minus 100. 260. So this side is 260. And if this side is 260 and this side is unknown, so PQR will be half of 260. That will be 130, 130. All right, so that's that.